Welcome to the Explainer. Look, if you're deep in study mode for a cloud certification, you know the deal. Those scenario questions can be really tough. So that's exactly what we're going to do today. We're going to take a classic cloud security incident and just break it all down, step by step, exactly like you'd face it on exam day. Okay, so here's the setup. An alert just fired. Something's not right with your API activity, and guess what? Your most critical data, the stuff encrypted with KMS, is right in the line of fire. So, what do you do next? We're going to connect all the dots here, see how these AWS services actually talk to each other, and how a real-world professional response is supposed to work. So, before that alarm even goes off, we need to talk about what should have already happened. See, a truly successful incident response, it's not about being a superhero in the moment. Nope, it's all about the prep work, the foundation you laid weeks, maybe months ago. And it all boils down to one of the most core concepts in all of AWS. You have got to know the shared responsibility model. I mean, it is the absolute bedrock. Think of it like this. AWS is responsible for security of the cloud. They build the fortress, right? The concrete walls, the security guards at the gate, the power grid, all that physical stuff. But you are responsible for security in the cloud. That means everything inside those walls, your data, your configurations, and crucially, who you give the keys to with IAM policies. Trust me, if you get a question on this wrong, you're not just dropping a point, you're fundamentally misunderstanding how cloud security works. And look, you can have all the cool automated security tools you want, but if you don't have a plan on paper, a well-documented incident response plan, you're going to have a bad time. This is about the people. Who gets that frantic call at 3 a.m.? Who's in charge of talking to the execs? This document is your playbook. It's what you grab when everything's on fire. Okay, prep work is done. Now, it happens. The attacker makes their move. So let's follow the trail. Let's trace those digital breadcrumbs and see exactly how a series of seemingly invisible API calls turns into a loud, flashing, impossible-to-ignore alarm. So first things first. Anything and everything that happens in your AWS account, and I mean everything, is an API call. And AWS CloudTrail is the service that's just sitting there recording it all. Seriously, think of it like the black box recorder for your entire environment. If something happened, CloudTrail has a record of it. It is absolutely ground zero for any investigation. Okay, so CloudTrail gives you this massive mountain of logs, potentially millions of entries. How on earth are you supposed to find the one bad thing? Well, the answer is you don't. Amazon GuardDuty does it for you. This is your intelligent threat detection. It's constantly sifting through all those logs, using machine learning to find weird, anomalous behavior that no human could ever hope to spot in real time. So GuardDuty spots the bad guy. Awesome. But then what? It can't just sit on that information. It sends its finding over to Amazon EventBridge. And this is a key service to understand. EventBridge is like the central nervous system for your cloud. It catches that event from GuardDuty and, based on rules you've set up, it triggers something else. It kicks off an automated response, maybe sends a message to Slack, maybe starts a Lambda function, all without a human having to lift a finger. You know, for the exam, don't just memorize this as a list of services. Think of them as a team. CloudTrail is the officer on the beat, writing down every single thing that happens. GuardDuty is the detective who looks at that logbook and says, hey, wait a minute, that doesn't look right. Then you've got things like Security Hub, which is like the command center, pulling all the reports together on one big board. The point is, they all have to work together to give you the full picture. All right, the alarm is blaring. We know we have a problem. Now, what's the immediate priority? Damage control. We have to contain this thing, stop the bleeding, and take back control. And in the world of AWS, containment almost always comes down to one thing: permissions. Okay, let's really nail this down, because this distinction trips a lot of people up. You've got KMS key policies and IAM policies. Think of it this way. A KMS key policy is a policy attached directly to the key. It's like the lock on a safe. It says, only Bob and Alice can even try to use this key. Then you have an IAM policy, which is attached to a person or a role, like Bob. It's Bob's ID badge. It says Bob is allowed to use KMS keys. For Bob to actually decrypt something, both policies have to say yes. The key policy has to let him in, and his IAM policy has to give him the permission. And this right here, this is the golden rule. Not just for IAM, but for pretty much all of cloud security. It's the principle of least privilege. Basically, never give anyone more permissions than they absolutely need to do their job. If someone only needs to read a file from a bucket, for the love of God, don't give them admin access. You always start with nothing and only add the bare minimum. Why? Because if that account gets compromised, the blast radius is tiny. So the official playbook for containment is pretty straightforward. Step 1, figure out the scope. How bad is it? What users, what machines have been compromised? Step 2, isolate. You've got to cut them off. Use security groups, policies, whatever it takes to stop the attacker from spreading. And step 3, this one's critical, take forensic copies. Before you go in and start fixing things, you need to create an exact encrypted copy of the compromised systems so you have evidence to analyze later. Okay, pop quiz time. This is a total classic exam-style question, so pay attention. You've found the compromised EC2 instance. You immediately go to its security group and add a rule to deny all traffic from the attacker's IP address. But you check the logs and their SSH connection is still active. Why? What's happening here? And the answer is because security groups are stateful. This is a huge concept. Stateful means that if a connection is already established, the security group just lets the traffic for that connection continue to flow. It doesn't recheck the rules for every single packet of an existing conversation. It's a performance thing. So your new deny rule only applies to new connection attempts. To kill that existing connection, you'd need to do something else, like use a stateless network ACL, or maybe even terminate the process on the instance itself. It's a subtle but super important detail. All right, deep breath. The attacker is boxed in. The immediate fire's out. Now comes the hard part, the cleanup. We have to go through everything, methodically, and get rid of every single trace of the attacker, so we can get back to a clean, trusted state. And when we say clean up, we mean a deep clean. This is eradication. It's not just patching one server. It's rotating every single access key that might have been touched. It's hunting down and deleting any sneaky IAM users the attacker might have created for themselves. It's finding and terminating any EC2 instances they launched. You are literally scrubbing the entire environment clean. Now, a massive word of warning here. This is important for the exam, but it's even more important for real life. When it comes to KMS keys, do not rush to delete them. Deleting a KMS key is an irreversible, potentially career-ending move. Once that key is gone, any data that was encrypted with it is gone forever, like poof, unrecoverable. The proper way is to disable the key first. That's reversible. Then you wait, you make sure nothing breaks, and you set up alarms to warn you before any scheduled deletion happens. Be so careful with this. And finally, we get to recovery. And recovery isn't just flipping a switch to turn things back on. It's about rebuilding, and rebuilding stronger. You don't just patch the sick server, you terminate it. You treat it like cattle, not a pet. You spin up a brand new, clean one from your golden AMI. You restore your data from backups that you know are safe. You patch everything. The whole point of recovery is to make sure the door the attacker used to get in is now bolted shut. Okay, we made it through the whole instant, from detection to recovery. So now let's just boil this all down. What are the absolute key takeaways you need to have locked in your brain for exam day? First, this framework. Memorize it. This is your mental map for any security question on the exam. Detection, analysis, containment, eradication, recovery. Before you even read the ABCD options, just ask yourself, okay, what phase of the incident is this question about? Seriously, just figuring that out can often help you instantly eliminate half the wrong answers. It's a huge strategic advantage. Second, this rule. If you remember nothing else about IAM, remember this. An explicit deny always wins. Always. It's the ultimate trump card. You could have 10 different policies that all say allow, but if there is just one statement anywhere that says deny, it's over. Access is denied. End of story. AWS is designed to fail securely, and this is how they do it. You will absolutely be tested on this. Third takeaway, automation isn't optional. It's not a nice to have. It's a flat-out necessity. You cannot do effective incident response at scale by having a human clicking around in the AWS console. It's too slow and you'll make mistakes. You have to be using tools like EventBridge to automatically trigger your response workflows. It's the only way to be fast, consistent, and reliable when the pressure is on. And that brings us to the big one, the final idea. You've contained the threat, you've recovered, but now what? How do you stop it from happening again? The real goal of all this isn't just to clean up today's mess, it's about learning from it. Every incident is a lesson. You take what you learned and you feed it back into your system. You build better alerts, you tighten up your security rules, you improve your automation, you turn today's crisis into tomorrow's strength. That's how you truly win at cloud security.